Today we are going to take a look at a very basic graphing technique question from TMJC. The hyperbola C1 has equation x minus 2 squared divided by 3 squared minus y squared divided by 2 squared equals to 1. Sketch C1 labeling the equation of the asymptotes and the coordinates of the axial intercepts. Now this question is pretty easy is because the form has been given in a way that we are very familiar with. So let's just take a look at this concept here. I can easily write down the point of intersection of the asymptotes. Based on this one, comparing to this, the point will be at 2, 0. And I'm going to write down the gradient of the asymptotes. I'm going to take the value below y, which is 2. So I have plus minus 2 over the value below the one with the x with 3. Alright, so making use of our secondary school building the equation of straight line, I'll be getting y minus 0 equals to gradient x minus x coordinate, which is 2. So now I'm going to go here. I'm going to plot this 2, 0 in to my diagram. And I'm going to draw two lines, one with a positive gradient, 2 over 3, that's slightly less than 45 degrees. So maybe somewhere this one here. Right, let me label as y equals to 2 over 3x. If I'm going to multiply this in, I'll be getting a negative 4 over 3. And to draw the other one, let me just extend this first. To draw the other line with a negative 2 over 3 gradient, I'll be having this line here. And I'll be labeling this line as y equals to negative 2 over 3x. Multiplying this negative value in here, I'll be getting a positive 4 over 3. Now, asymptotes line is out. Next, we know that this shape, x minus y version, is going to be somewhere over this side and this side here. So I'm going to plot two more important points. Moving this point, 3 units to the right. 2 plus 3, I'm going to get a 5. So roughly this point here, 5, 0. 2 minus 3 will give me a negative 1, probably somewhere here, negative 1, 0. And we're going to draw the graph now. This side approaching asymptote line, and also this line here approaching asymptote line, and one more, which is this side, and this side over here. All right, and now we're done with the first part. The next part, we have the curve C2 with an equation. Let me write this down. X minus 2 squared plus y squared equals to k squared. This is something that we are very familiar with. It's a circle. So this is a circle with center of 2, 0. And the radius of the circle is k. Now I'm going to try put a circle into my diagram. 2, 0 is here, the center of circle. And let's read the question. The curve C2 has equation of that and state a value of k such that C1 and C2 intersect exactly twice. In order for me to draw a circle that intersects the curve C1 exactly twice, I'll be sketching something touching here and here. So that's 1 point intersection, 2 points intersection. So the radius of the circle will be 3. Alright, so if I'm going to complete the circle, now you can just find out this is a 4 over 3 just now. So by calculating the distance, I'll know that the circle will be slightly above here. Alright, so same to this point, I'll be drawing a circle slightly below that point. Alright, so if we are finding a distance, it will be less than the radius circle. So my circle will be roughly this way. So answering the question, therefore k will be equals to 3 in order for this C2 to be intersecting C1 at 2 points.